Installing a new uninterruptible power supply, or UPS, unit introduces several potential hazards that should be avoided. This includes electrical, mechanical, chemical, and environmental risks. When installing a 208 volts 20 kilowatt unit, it's crucial to be aware of these hazards and take appropriate precautions. Firstly, let's discuss the electrical hazards. High voltage, specifically 208 volts alternating current, is present and poses a significant risk of electric shock. There is also direct current, or DC voltage from the battery system within the UPS, which can also be dangerous. Secondly, there are mechanical hazards. The UPS equipment itself is often heavy and difficult to maneuver. Sharp edges on the equipment and potential pinch points during installation can cause injuries. Thirdly, chemical hazards are present due to the battery electrolyte, which can be either acidic or alkaline and cause burns or irritation. Finally, environmental hazards include heat generated by the UPS during operation and noise produced by the system's cooling fans. To avoid these hazards, several safety measures should be implemented. Let's start with electrical hazard avoidance. The first step is to use proper personal protective equipment, or PPE. This includes wearing insulated gloves, safety glasses, and non-conductive footwear to protect against electric shock and arc flashes. Secondly, follow lockout-tagout procedures to isolate and to energize the power source before working on the UPS. This ensures that the system cannot be accidentally powered on while someone is working on it. Thirdly, use insulated tools that are specifically rated for high voltage work. This helps prevent accidental shorts and electrical shocks. Fourthly, avoid direct contact with electrical components by keeping hands away from exposed terminals, wires, and circuit boards. Fifthly, always test for voltage using a voltmeter to verify that the system is energized before beginning any work. Now, let's move on to mechanical hazard avoidance. When lifting and carrying the equipment, use appropriate lifting equipment such as forklifts or pallet jacks, and follow proper lifting techniques to prevent strains and injuries. Next, secure heavy components by ensuring that all equipment is properly bolted down or braced to prevent it from falling over. Cover sharp edges and pinch points using guards or padding to prevent cuts and other injuries. To mitigate chemical hazards, handle batteries with care by always wearing gloves and eye protection when handling batteries or working around the battery compartment. Dispose of batteries properly by following local regulations for the disposal of hazardous waste. Avoid spills of electrolyte by taking precautions when handling batteries and immediately containing and neutralizing any spills according to the manufacturer's instructions. To address environmental hazards, provide adequate ventilation to prevent overheating, as UPS systems can generate significant heat. Also, reduce noise levels by using sound-absorbing materials or noise barriers to minimize noise pollution. In addition to these specific hazard avoidance measures, there are some additional tips to keep in mind. Firstly, carefully read and follow the manufacturer's instructions for installation and operation. Secondly, ensure that all personnel involved in the installation are properly trained on safety procedures. Thirdly, conduct regular inspections of the UPS system to check for any potential hazards and address them promptly. If there's any electrical work during UPS install that is uncomfortable to perform, consult a qualified electrician. Electrical hazards associated with UPS installation are significant and primarily involve the risk of electric shock from high voltage alternating current and direct current sources. The 208 volts alternating current power supply to the UPS poses a serious threat, as contact with live conductors can result in severe injury or death. The UPS battery system, which typically operates at a substantial direct current voltage, also presents a shock hazard. When working with electrical components, it is imperative to implement stringent safety protocols. Firstly, always wear appropriate personal protective equipment, including insulated gloves, safety glasses, and non-conductive footwear. Insulated gloves provide a barrier against electric shock, while safety glasses protect the eyes from potential arc flashes or debris. Non-conductive footwear prevents the body from becoming a path to ground, reducing the risk of electric shock. Secondly, adhere to strict lockout-tagout procedures to ensure that the power supply to the UPS is completely de-energized before commencing any work. This involves disconnecting the UPS from its power source and applying a lock-in tag to the circuit breaker or disconnect switch to prevent accidental re-energization. Thirdly, use only insulated tools that are specifically designed and rated for high-voltage applications. Insulated tools provide an additional layer of protection against electric shock, reducing the risk of injury if contact is made with live electrical components. Fourthly, exercise extreme caution to avoid contact with any exposed electrical terminals, wires, or circuit boards. Maintain a safe distance from these components and use appropriate tools and techniques to prevent accidental contact. Fifthly, always verify that the UPS system is completely de-energized before starting any work by using a calibrated voltmeter to test the voltage at various points within the system. This confirms that the power supply has been effectively disconnected and that it is safe to proceed. Mechanical hazards during UPS installation primarily involve the risks associated with handling heavy equipment, sharp edges, and potential pinch points. The weight of UPS components, such as batteries and power modules, can lead to strains, sprains, and other injuries if not handled properly. Sharp edges on the equipment can cause cuts and lacerations, while pinch points can result in crushing injuries. Firstly, use appropriate lifting equipment, such as forklifts, pallet jacks, or cranes, to move heavy UPS components. Ensure that the lifting equipment is in good working condition and that operators are properly trained in its use. Secondly, follow proper lifting techniques such as keeping the back straight, bending the knees, and maintaining a firm grip on the load. This minimizes the risk of back injuries and other musculoskeletal problems. Thirdly, secure heavy components to prevent them from falling or shifting during installation. Use bolts, brackets, or other appropriate fasteners to ensure that all equipment is properly anchored and supported. Fourthly, cover any exposed sharp edges or pinch points with guards, padding, or other protective materials. This reduces the risk of cuts, lacerations, and crushing injuries. Chemical hazards associated with UPS installation primarily involve the risk of exposure to battery electrolyte, which can be either acidic or alkaline depending on the type of battery used. Battery electrolyte is corrosive and can cause severe burns to the skin, eyes, and respiratory tract. Firstly, always wear appropriate personal protective equipment, including gloves, safety glasses, and a face shield when handling batteries or working around battery compartments. This protects the skin, eyes, and respiratory tract from exposure to battery electrolyte. Secondly, handle batteries with care to avoid spills or leaks. Use proper lifting techniques and avoid dropping or damaging the batteries. Thirdly, dispose of batteries properly in accordance with local regulations. Batteries contain hazardous materials that can contaminate the environment if not disposed of properly. Fourthly, contain and neutralize any electrolyte spills immediately. Use appropriate spill control materials, such as absorbent pads or neutralizing agents, to prevent the spill from spreading and to minimize the risk of exposure. Environmental hazards associated with UPS installation primarily involve the risks associated with heat generation and noise levels. UPS systems can generate significant amounts of heat during operation, which can lead to overheating and equipment failure. High noise levels from cooling fans and other components can cause hearing damage and create a disruptive work environment. Firstly, provide adequate ventilation to dissipate heat generated by the UPS system. Ensure that the installation location has sufficient airflow and the ventilation openings are not obstructed. Secondly, use sound-absorbing materials or noise barriers to reduce noise levels. This can include acoustic panels, soundproof enclosures, or ear protection for workers in the area. To ensure the safety of personnel during UPS installation, it is crucial to provide comprehensive training on all potential hazards and the appropriate safety procedures. Training should cover electrical safety, mechanical safety, chemical safety, and environmental safety, as well as the use of personal protective equipment and the proper handling of UPS equipment. Regular inspections of the UPS system and the surrounding area can help to identify potential hazards and ensure that safety procedures are being followed. Inspections should include checking for loose connections, damaged equipment, electrolyte leaks, and inadequate ventilation. If there is any doubt or uncertainty about the safety of a particular task, it is always best to consult with a qualified electrician or other safety professional. They can provide guidance on the proper procedures and precautions to take to minimize the risk of injury or equipment damage. In conclusion, the installation of a new UPS unit involves a variety of potential hazards that must be addressed to ensure the safety of personnel and the proper functioning of the equipment. By following the safety precautions outlined in this discussion, these risks can be minimized and the installation can be completed safely and efficiently. Electrical hazards necessitate stringent adherence to personal protective equipment protocols, comprehensive lockout-tagout procedures, and the utilization of insulated tools. Mechanical hazards demand the implementation of appropriate lifting methodologies, meticulous equipment securing measures, and thorough safeguarding of sharp edges and pinch points. Chemical hazards mandate meticulous battery handling practices, stringent spill containment protocols, and meticulous disposal procedures. Environmental hazards necessitate the provision of adequate ventilation and the implementation of noise reduction strategies. Furthermore, comprehensive training, regular inspections, and the availability of expert consultation constitute indispensable components of a robust safety framework. Firstly, it's very important to utilize proper personal protective equipment. This is a cornerstone of electrical safety. Secondly, adhering strictly to lockout and tagout procedures is absolutely crucial. Thirdly, when it comes to tools, selecting and using insulated tools is indispensable for preventing electrical shocks and ensuring a safe working environment. Fourthly, regular inspections are also a crucial element of a comprehensive safety program, as these inspections help identify potential hazards before they can lead to accidents. Fifthly, continuous training and education for all personnel involved in the installation are paramount. Proper training ensures that everyone is aware of the hazards, knows how to use safety equipment, and understands the correct procedures to follow. Sixthly, maintaining a clean and organized workspace is surprisingly important. A cluttered workspace can increase the risk of trips, falls, and accidental contact with hazardous materials or equipment. Seventhly, when working with batteries, meticulous handling and storage procedures are essential to prevent electrolyte spills and other chemical hazards. Eighthly, it's important to assess the location. Conduct a thorough risk assessment of the installation location to identify any specific hazards or challenges that may be present. Ninthly, communication is also a critical aspect of safety. Ensure that all team members are aware of the work being performed and any potential hazards that may be present. Tenthly, having emergency procedures in place is a must. Establish clear emergency procedures for dealing with electrical shocks, chemical spills, or other accidents that may occur during the installation process. Finally, staying updated with safety regulations and standards is crucial. Keep up to date with the latest safety regulations and industry standards to ensure that your installation practices are compliant and that you are using the most effective safety measures available. Remember that safety should always be the top priority during any UPS installation project. By taking the time to plan ahead, implement appropriate safety measures, and provide adequate training, it is possible to minimize the risk of accidents and injuries and ensure that the installation is completed safely and successfully. Now let's consider a hypothetical scenario. Imagine a situation where a technician is rushing to complete a UPS installation and neglects to properly lock out the power source. In this scenario, the technician could inadvertently come into contact with live electrical components, resulting in a serious electric shock. This is why lockout-tagout procedures are so crucial. They provide a physical barrier to prevent accidental re-energization of the equipment while work is being performed. Another scenario involves a technician who is not wearing safety glasses while working with batteries. If battery electrolyte were to splash into the technician's eyes, it could cause severe burns and permanent vision damage. This highlights the importance of wearing appropriate personal protective equipment at all times. Consider a situation where heavy UPS components are not properly secured and they fall, causing injuries to workers or damage to equipment. This underscores the need for proper lifting techniques, securement methods, and regular inspections to identify potential hazards.